All right, nest makers, we are talking about our push block today. We are waking up our brains just 20 minutes or so, maybe a little bit more, a day. We can make a nest game this month, and we are continuing on our quest to build these cool little mechanics that we can then snap into a game, which we're going to have to turn the corner on soon because let me tell you, a lot of you guys have built like these really cool mechanics and things like that and then just forgot about making a game out of it. So don't worry, we're going to go over sort of that too, just like how we went over a little aesthetics. We'll go over a little narrative. We'll go over all the sort of details. And we want to start moving forward towards that area, but we got to finish our push block first. Now, today is day 17, and I couldn't find a lot of significance for the number 17, but I did find this. Individuals born on the 17th are natural leaders, independent, ambitious, and innovative, who are able to pave the way forward with their determination and charisma, combining practicality with big dreams. And what better summation of creating this game could there possibly be? We are going to do that. And we are going to be positive and determined today because we do have a bit of coding to do to make this work. If you've been following along, this shouldn't be too hard, but it might be the most coding that we've done so far. There are multiple ways to do what we're trying to do. And I'll show you what we've got going on right now in case we need a reminder or you're doing these out of order. What we've got going on right now is, I slowed it down the last time I had this open. Sorry. There we go. We have right now is we have this push block, and if I press it, it changes, right? And we got to do multiple things. One, we got to get it to move in the direction that I'm facing. And the other thing is that's going to start it moving. And the next thing I got to do is I've got to make it so that it stops on the next possible line. And the last thing we want to do is we want to say that, okay, if it ends up stopping on a line and the tile at that space is a target tile or whatever, something happens. And we're not going to be able to make anything crazy happen today. We're just not going to have time. But we can at least trigger a reset so we know, hey, we did it, and something should happen. So maybe it turns into a diamond. Maybe it turns into a monster. Maybe it turns into a door or a warp, whatever. So that would be a good one. It turns into a warp. Maybe we can do that. Okay, so anyway, one of the first problems we have is you can see I could walk right through the block, and we don't want that. We don't have a way to make an object solid, but there is a trick we can use in this module. If I go to Object Details, I can go to Details, and I can make it an NPC type object. And what's great about this is we don't trigger NPC dialogue in this. So we can use the NPC type, and as long as I don't include the trigger, the NPC trigger, it won't try and trigger dialogue. All it'll do is it'll prevent me from walking through it. If I do end up adding text, what I'll have to do is I'll have to write a caveat to see, okay, what kind of object am I running into? If it's a push block, ignore triggering the NPC. That's basically all I would have to do. That wouldn't be too hard. But now if I test my game again, what I should see is as soon as it's turned into a game object from a tile, it's solid and I can't walk through it anymore, which is the behavior I want. And that is the behavior I get. Awesome. So off to a good start. Now we got to get this thing moving. And the challenge is going to be, I've got to get it moving in the direction that I'm facing. So first, let's just get it moving to the right. And what I want to do is immediately, as soon as this happens, if I go into my prize block. So if you have to get there, we go into script settings, down to tiles, and go into your prize block, your custom prize block script, which was push block. I'm sorry. Go to my push block script. Right here, when I'm creating it, this is what I want to determine. I also want to determine which way it's moving. So here's what's neat. Throughout all this, we talked a little bit about this. We have what is in Xavier, the object that Xavier, the register X is holding, is my player object right now. And that's why I had to do this. This is what happened yesterday that we had a little glitch, right? I had to push Xavier to the stack, and then I had to restore him because this is going to corrupt Xavier. So before I do this, Xavier is set to my player. After I do this, Xavier is set to this new object, and then I continue on. So what I can do is at this point, right before I do all that, I can get the player's direction. I can say load object direction, comma X. And I'm going to and in these last 1, 2, 3. Okay, these last 3 bits. And if we need reference for that, here it is. 0, 0, 0 equals down. 0, 1, 0 equals right. 1, 0, 0 equals up, and 110 equals left. And all the other ones are the down right, down, up right, up left, and down left. But these are the values that I want to stay cognizant of. I'm going to need to know which way he's facing so I know which way to push him. But what I'm going to do is I'm going to take these bits and I'm going to store them into a variable like temp_a. Okay, I'm not using temp_a. I'm not corrupting it anywhere, so I can use it. And what I want to do is when this object is created, now this object is in Xavier. So I can now set this variable to the direction of this object. So I'm going to say right here, I'm going to say load temp_a and store it into object direction, x. So this object is now what's in Xavier until I restore the player. Right now, I push the player to the stack, pull the player back off the stack. But in this whole player, anything that's referencing x is referencing this new object I created. So what I did was I'm holding, so if it's down, this is now says down, and I loaded down and I put it in this new object's direction. Pretty neat. Now I'll be able to read that direction to know what should happen. So the first thing I want to do is I want to bump it. I don't want it to start moving yet. I just want to bump it off of the grid because I'm going to use a different script to check to see if it's on a grid. And if it's on a grid, I'm going to start my inertia to get it moving. And if it's on the grid, it'll take one frame for it to actually move. So but if I want it to get destroyed when it lands on a grid, it'll get destroyed on the next frame because it'll still be on the grid unless I bump it off the grid. You'll see what I mean as we do this. So what I'm going to do is if it's moving down, I'm going to say I'm going to load. I don't even have to load it because it's already in the accumulator right now. So it's already in the accumulator. And I could say I'm going to compare that I could say I want to compare it to 0, but I could say BEQ, which means if it equals 0. I want a branch if it's equal to 0 to is moving down. And I'm just enter down is moving down. Now in the next line, it's not equal to down. So not equal to down. I could say load object direction, comma x. And I'm going to compare it to 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0. That would be right. If it's that, I would say is moving right. So I'll come down here. I'll make it is moving right. I'll do this exact same thing. I'll say here it's not moving right. Moving right. I'll paste this in, except now I'm going to compare it against 1, 0, 0. BEQ would be is moving left. And I'll make a is moving left. And then I'll do the exact same thing. Not moving left. So the only other option is really, I'm sorry, this is up, not left. Let's move it up. Oh, it's early. And then this one is the only direction left. Is BQ is moving left. And honestly, this is redundant because the only other option that it could be is moving left. So I could have just had moving left right here. The first thing I'm going to do is I'm going to bump it off the grid. So everything here, there's no other option. So it's either moving down, moving right, moving up, or moving left. So if I'm moving down, I want to move its Y value off the grid. So I'm going to load object Y high, comma X. I'm going to add 2 to it. And then I'm going to be done. And to be done, I'm going to jump to here with moving block. Give it a name. So I'll come down here. Done with moving block. So it's going to move down by 2. And it's going to jump to here. So it's going to skip moving to the right. So now, same thing. Copy that. Moving right, I'm going to update X by 2. And then I'm going to jump to done moving block. Now, moving up and down is a little bit weird. So moving up, I want to change y. I could subtract 2. That's one way I could do. I want to get used to this. I want to add, and I want to add, how much do I want to add? If I added 2, it would move over to the right 2. If I moved 1, it would move over to the right 1. If I added 0, it would stay still. So if I wanted to add -1, it would move up 1. I'm sorry. I'm talking up and down, not left and right. Sorry. I would move up 1 because I'm moving in a negative direction. How do I write that? Well, we've got an 8-bit number. And an 8-bit number goes from 00 to FF. FF is equal to 255. So if I said this, it's exactly the same as saying -1. If I said this, it's exactly the same as saying -2. I'm now moving backwards through my numbers. So FF, FE, FD, FC, FB, FA, F9, F8, F7, F6, F5, F4, F3, F2, F1, F0. I've just moved back 16. So hopefully, and then I would go to EF. EE, ED, EC, etc. Then I would go to D, and eventually I'd go all the way backwards to 00, right? So do the same thing here. Jump, done with moving. Oh, I already have that. Sorry. And then I want to do with left. It's going to be this, but it's going to be X. So I'm adding a negative number effectively. That's how this is working. And I just wanted you to see that because it's another way to work with numbers. And sometimes you're going to prefer doing that. I don't have to jump to the moving block because it's going to flow right into that. So now it should bump it off the grid. Now, it might be hard to see because it's only bumping it by 2 pixels. But let's make sure that we don't have any errors or anything like that here. I'm going to test this. Okay. And when I hit it, it should bump it off the grid. And it was hard to tell, but it did bump. I can kind of see right here, if I look straight down, it's off the grid, successfully off the grid. So if I Control T, I can reset the game. Let me try and bump it up off the grid. And again, it's kind of hard to see, but if you went straight over, you can kind of see that it's off the grid. If I went straight over from here, it's off the grid by about 2 pixels. Awesome. But now we got to get it to actually move in that direction. Now, I was having a little bit of funny behavior where it was acting backwards with movement. We're going to see if that happens again. So what I would expect, and this is what didn't work the way that I thought it should, and I think it has to do with the collision happening with the player. But what I want to have happen here is I'm going to load the number 2. And I'm going to, if I'm moving right, I'm on moving right now. I'm going to store it to object h speed high, comma x. This is going to start moving in a horizontal direction of 2. Now, what I think is happening is as soon as I touch it, as soon as it's created, it actually reverses its direction and starts moving the opposite direction because there was a collision between the player and the quote-unquote monster object. And I think by default, the behavior is that it'll start moving in the opposite direction so that a monster doesn't keep running into a player. And so I think that's baked into my object collision routine. If that's the case, I'm just going to have to flip this and make it a -2. But let's take a look. This should make it start moving right if it was facing to the right. Yeah, you see how it moved left? Weird behavior, but like I said, I think it has to do with, I think I can understand why it's doing that. If we want something to move to the right, this is the way to do it. But I think the collision between the player and the object is what's throwing it off. All I got to do to make this work right is I'm just going to change that and reverse it to FE. That's -2. We just figured that out over here. Now it will move in the correct direction. Only right though. So now we got to go in. Boom. And if I wanted, maybe that's what I want. It stops when it hits the wall. So I'm going to do the same thing for moving down. But I'm going to change the vertical speed, not the horizontal speed. And then for up and left, for up, I want it, I'm going to change it to O2. And it's going to be the vertical speed. And going left, it'll be O2. Oops. O2. And that's the horizontal speed. So now each direction, if I'm moving down, it bumps it, and then it starts moving it with factoring that we've got that weird thing happening with the collision making it swap directions. So it starts moving it in the vertical speed. If I press it right, it's going to bump it, and then it's going to start moving it right. If I am moving up, it's going to bump it and then start moving up. And if I'm moving left, it's going to bump it and start moving left. So this is the same thing over and over again. It looks like a lot of code, but it's just the same thing over and over again with the different sort of numeric values pumped in there for making it move in the various directions. So save that. And now what we should have is boom. And if I go up, boom. And if I go down, boom. And you know what I'm going to say with the last one? If I go left, boom, boom, boom. We got all 4 directions moving. Very cool. We got a block puzzle thing, and in less than 35 minutes, because 20 minutes yesterday, 15 minutes today. Now the harder part, though, this is why we're going to extend to probably 30 minutes today, because I want it to stop after it goes one single block. I don't. If you're happy with it going all the way across the screen, if that's the mechanic you want, we got it. You got it, and we could figure out the rest from here. But I want it not to do that. I want it to stop on the next possible frame. So that means as soon as it lines up with the grid again, I want it to stop. And what I can do to do this is I'm going to use my pre-draw script again. Remember we did this, we did some stuff with timers and stuff in the pre-draw script. Now, I'm not saying this is the best place to do this, but if I go into my pre-draw script, I can do all kinds of things in here because I know that this script is being checked every frame. And there is some room in the bank where this is in for us to have a little bit of play. So as long as there's room in the bank, this is a great place to do things if you need stuff to happen every frame. We're going to do a loop right now. So what we would need to do is we need to look at all of the active objects on the screen. And we need to see if that active object is a push block. That's what we're doing right now. Okay. So what I'm going to do is I am going to, I could back up X, like I could do the same thing I've been doing like this, and then pull A and TAX. This backs up X and restores it because I'm about to corrupt X. But you know what? This drawing is happening when a time where that shouldn't matter. But just in case, it's really good practice anyway. So I'm going to put that in there. I'm about to corrupt X. I'm going to say I'm going to load X with the number 0. We're going to use Xavier to do a loop. And I'm going to put do block loop. So I know what this is. And maybe at the beginning of this, I can say handle push block grid movement. Okay. So now in this block loop, what I want to do is I first want to check this object, whatever object I'm on, whatever Xavier's holding on to, check and see if it's active. And I can do that by saying load object status, X. So it's now looking at the object status of whatever Xavier's holding. Right now it's holding object number 0, which is so basically you have slots for your different objects. If I look at object variables, I've got 13 slots for objects in this. And you can kind of see why. These are all of the variables that it takes to make an object. Its position, its status, what type it is, what frame its animation is on, all that, its health, all that stuff. This is what makes an object in this module. And I have a space of 256 bytes. I'm using 247 bytes because this number times the number of this gives me 247. If I add one more, I'm over 256. I'm going to start to encroach on other variable area where I've got different RAM, where I've got other things that I'm keeping track of. I could have all the way up to 13 objects active on a screen at one time in this module. If you reduce the number of this, like if you didn't ever need ID and type and frame, you might be able to get more objects than 13 on the screen at a time. Right now, basically I have 13 slots for objects at a time. I'm going to check each slot. That's what Xavier is going to do right now. So I'm going to check object status, and I'm going to check bit number 7, which is, this is how I check bit number 7. If that is equal to 0, that means I am not active. If it is not equal to 0, it means this object is active on the screen right now. So I'm going to say BNE is active. Enter down is active. Okay. If it is not active, I'm going to jump to done with this object and come down here somewhere and say done with this object. Now, we'll come back to active in a second. If I'm done with this object, what I want to do is I want to increase X. So if I was looking at object 0, now I'm looking at object 1. If I'm looking at 1, I'm looking at 2. If I'm looking at 2, I'm looking at 3. I'm going to increase it and I'm going to look at it and see if it is equal to a total max objects, which is a constant that gets spit out by this number. So whatever number's here is what, so I'm now going to check 13 slots. If I change this number to 10, it's going to check 10 slots because there's only 10 spots where an object can possibly be. All right, so I'm checking against the total max objects. If it's equal to that, that means I'm done. I am done. So I'm going to enter down. All right, I am done. But if I'm not, I'm going to keep looping. So that means I've increased X, so now it's 1. I'm not done yet because 1 doesn't equal 13. So now I'm going to jump to do block loop, and it's going to do it again. It's going to check the status of object number 1. Let's say that it was inactive. Okay, now I'm down here. I increased to 2. That doesn't equal that. I'm not done yet, so I'm going to jump back to it. Now it's on 2. It's going to do 2. Now it's going to do 3. It's going to check 4. It's going to check 5, all the way to 13. All right. So what happens if it is active, though? Now I knew it. We're at 20 minutes. All right. So if it is active, this is where I want to start doing some different things. I want to check to see if it's lined up to a grid. And the problem is that if I'm moving laterally, if I'm moving horizontally, then my vertical position is going to be locked on a grid. It's going to be 0. If I'm moving vertically, my horizontal is going to be locked on a grid, and I want to be checking vertical, right? So what I could do is I could load, say, object h speed, comma, underscore high, comma x, all right? If this is 0, BEQ, branch if equal to 0, then that must mean I am moving vertically. Okay, which means this would mean I'm moving horizontally. Because if my h speed is not 0, that means I'm moving this way. I'm moving horizontally. If my h speed is 0, I'm moving this way because my h speed wouldn't be changing if I'm moving that way, right? All right, so if I am moving horizontally, let's take care of this one first. What I want to do is I want to load object x high. I want to load his x position. And I'm going to and in the last bits. This will be multiples of 16. This is the remainder. So if I think about my grid positions as 0, 16, 32, 48, 64, etc., right? If I think about it like that, this is the remainder. So as I'm moving by 2 pixels. We set it at a speed of 2. So I'm going to start at, let's say I'm up at the top left corner. I start at 0. As soon as I touch it, it goes to 2. And then since I'm moving at a speed of 2, on the next frame it's going to be 4, and then 6, and then 8, and then 10, and then 12. And when it gets to 16 written in hex looks like this. Don't write this, but 16 written in hex looks like this, right? It's on a grid. So these bits, 16 written in binary, looks like this. Don't write this. Looks like this. This is 16, and multiples of 16 are going to increase this half of the byte. That was called a nibble. So if this ends up being 0, that means I'm on a grid. And that's when I want this thing to stop. So what I'm going to say is if these bits, I flagged off these, I'm not worried about these. If these bits right here are 0, I want to basically stop this thing from moving. If it's not 0, I just want to keep going. So I'm going to say branch if not equal, I am done. Right there. So if it's not equal to 0, I'm sorry, nope. We could probably best to do done with this object, just in case in some scenario there are multiple blocks moving at the same time. I don't think there could be in this scenario, but just in case, it'll check all the objects, and it should only be triggering this one. If I am, so this would mean I am lined up with a grid. What we want to happen if I'm lined up in the grid? Right now, I want to destroy object. That's all I want to do. And destroying the object, it's just going to literally go away. And then I'm going to jump to done with this object. So it's just going to go away. And then I'm going to do the same thing for vertically, except I'm not checking. I'm not checking is object's X value. I'm checking whatever object is in Xavier. I'm checking its Y value to see if it's lined up. And if it is, I'm lined up with the grid. Okay, so like I said, there's a lot of code, but hopefully it's not too hard to understand. We now have this happening. Uh-oh. What did I do wrong? Uh-oh. I checked its status. Oh, I forgot to check its type. I'm sorry. We got one more line to do. So if it's active, I also have to check to see if it's a push block, because right now the player was lined up to a grid, so it got destroyed. So, okay, if it's active, I'm sorry. I have to load. So right after it's active, we're going to load object type, comma, X. And we're going to compare it. What type is it? 0, 1, 2, 3, 4. We're going to compare it to 04. If it's not equal to 4, then I'm not worried about it. So where am I going to go? I'm going to be branched done with this object. I'm not thinking about it. Done with this object. Okay, and to make this a little bit easier to read, I'm going to take all that and tab it in. So done with this object. I'm going to jump down here. Then I'm going to check to see if it's on the grid. So now, I'm sorry, the only thing I'm going to be checking is the block. Boom. And if I slow that down by hitting the minus sign, I can do that on the Messen emulator. Plus sign will increase. If I slow it down, I can see that as soon as it gets, if I can imagine the block would be right about here, as soon as it lines up with this next position, you're going to see that that's when it disappears. All right? Right there. As soon as it lined up, it disappeared, which means we're on the right track. And there's one more thing that we've got to do. We've got to change the tile at the position that it's in. So do you remember how we did this before, where we had to like change the tile and stuff like that? Man, I can't remember how we did it. We did this, right? We did this. We got the collision table, and we found the position that it was in, and that's how we found that we created the object. We need to almost do the reverse of this. We need to find out where this tile is located, and we need to create a new, or this object is located, and we need to create a tile at the position of that object. And to do this, we are going to, there's another script that is not in these modules, that I'm not sure why it's not in these modules, but it's change tile position, which would be a really easy way to do this. But we are going to hijack the change tile at collision, what do we want to call it? Change tile at collision macro. So if I look at that real quick, I'll pull it up here. This is what we need to do. For tile type number 1, for temp 1, we need to push the grid space into tile 1. So how are we going to, or temp 1, and then we should be able to run this as normal. This is the hard part right here, is pushing this into temp 1. So what what might happen is there might be another macro called like get tile position or something like that, and maybe that's why it wasn't included. It was two separate things, but I'm not that worried about it. What we're going to do is we're going to find the tile type, and we're going to put it in the temp 1. We're going to use some of the same skills that we've been using. So if I look at my screen and I turn on my grid, all these are tiles. So 0 through 0F, 1 through 1F, 2 through 2F, 3 through 3F, etc., all the way down to E through EF. There's no F0 through FF because there's only 240 pixels vertically. Okay. So anyway, what I want to do is I need to translate object position, as X and Y, into tile coordinates. So how do I do that? Well, let's jump back over to where we want this to happen, which is in my pre-draw. And let's deal with horizontal first. So before we when we destroy the object, I could even do something like this. So I only have to do this one time. Instead of jumping here, I'm going to put a nice little funky extra label right here. And this is going to be update object to tile or something like that. Okay. And instead of jumping to done with this object, it's going to jump to that. Once after I've destroyed the object, it's going to jump to this. Before I design before I destroy the object, what I'm going to do this is, and again, this is a little bit complicated with 8-bit math. This may be the most complicated we have to think out today, but if we get this, man, we are doing some cool stuff. So what I want to do is I first have to figure out the y, because that's going to give me 0. It's going to be basically my quote unquote tens place, even though that's, in hex value tens place. So this would be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, A0, B0, C0, D0, E0, right? And then what I need to do is I need to take the highest significant nibble of the X and I need to push it over. So what's going to happen is this is really 16, right? If I look at X value, 0, 1, 2, 3, 4, 5, 6, 15, this would be 16. And if you remember how I drew 16 just a minute ago, it was this, right? 0, 0, 0, 1, 0, 0, 0, 0. I drew this. What I want to do is I want to take the y value, which would be this part of the number. And I'm just going to dash these out. I want to take this part, and that's going to determine my tens place, 0, 0x, 1x, 2x, 3x, 4x, 5x, 6x, 7x, okay? And then I want to take this part and I want to bump it over to here, because if this is 16, think about where this would be on the grid. This would be here on the grid, right? How many tiles is that over? 1. This would be 32 on the grid. And how I would write that would be this. That would be 32. This would go here. And so what I would get is I'd get 0 down and then 2 over. So anyway, what we're trying to do is we're using the highest nibble of the y value, and then we're taking the highest nibble of the x value, and we're moving it over into this spot. So that will give us what our collision grid position is going to be. All right, so here's how we'll do that. We will load object y high, comma x, and 1, 1, 1, 1, 0, 0, 0, 0. That's the high nibble of its y position. So now I basically have the tens place of where my grid position for the player is. I'm going to store that to temp A. I'm not using temp A here, so that's okay. And now I'm going to take load object x high, and I'm going to bump it, shift it to the right by 4. That's basically dividing by 16. I'm going to OR in the temp A. I'm going to store that. And I can store it to temp A, I can store it to temp B, I can store it just to keep it easy so it's not confusing. OR in, or I'll put combine the high nibble of position with low nibble of x position, y position. So that's what this is actually doing. All right, and then I'm storing it, what I get out of this variable. This is now going to be what's pushed into temp 1. And honestly, this right here, I can cut it right out of here. And I can paste it here, because that's what doesn't matter whether I'm moving vertically or horizontally. This is what update this tile is going to mean. So do that. So this is going to go here. This is going to go here. And either way, it's going to do this exact thing. And it's going to update the tile. And this, honestly, what I want to change this to, not temp B, it's to temp 1. So what I'm going to do is I'm going to change that to temp 1. And then, now that I've got basically the grid position, so I can even put here, this gets grid position on a 16 pixels by 16 pixels grid. Okay, so now that I've done that, that's what this part does. I'm going to store this grid position into temp 1, because that's what change tile at collision needs to see. So store temp 1, and now I could change. So now I've made a fake collision position. So I can use a change tile, and I can say what tile I want to change it to and what collision I want to change it to. So this is where I'm going to get different. I don't want it to change it to 0, 0. What I want to change it to is I want to change it to this one right here. So what I have to do is I have to sort of count. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So this is 0, right? But then I just have to skip one. So this is 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. So this would be 4, 0. This would be 6, 0. This would be 8, 0. So this would be 8, 0, 8, 1, 8, 2. That's what I want to draw is 8, 2. So what tile do I want to draw? I want to draw 8, 2. And what collision do I want it to be? I want it to be, let's say, I want it to be a push block again, which a push block was, if I look at my collision, was tile type number 11, which is hex 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. So what I'll do is I'll hashtag $0B. Save that. And so now it'll change that into this tile and this collision. And I think I did that right. Let me just check that out. I always forget how this change tile, the numbers work, but I'm pretty sure in this module, that's how they work. Oh, branch out of range. Notice we get these branch out of range. This is going to be a pretty common thing once you start doing code. And what it means is we're doing a BEQ or a BNE. We're doing a branch, and it's trying to branch too far. So what we got to do is we got to invert that. So I'm going to go to 180. Look at this. I need to say BEQ. I need to invert this. BEQ not done with this object. And then I can jump to done with this object. And then here's I'm going to put not done with this object. And I have something similar a couple lines further down. So I'll just run it again. We'll see what the next position was. It's going to be the same things. It's going to be a branch out of range error. Man, this video went way longer than I thought it would. Oops. Let's see where that said. Sorry. So again, we're at 180 branch out of range. Did I not save it? I didn't save it. Sorry. So I saved it, and now I'll have 2 left to fix. And it tells me 188 because I'm bumping it right every time I'm adding some more code. So 188 is this one. I'm going to say BEQ not done with this object. Jump done with this object, and then after that, but not done. So that means the branch is moving less, and then less far. It only has to move this far, and then I'm jumping to where I need to go. Let me just make sure that I'm doing this right. Okay. Kind of doing it fast, so save it again. Sorry. Trying to do things too fast, and I'm going to let things slip. I should have 1 left. Sorry. One more time. 199 branch out of range, which is here. Same problem. So I'm going to change this to BQ. Not done with this object. Jump done with this object. Not done with this object. Okay. So now I've inverted all those. So the branches only have to jump this far. And then, so instead of BNE done with this object, it's BEQ not done with this object. It's the opposite. And then I use when it flows in the next line of code, it jumps. Hopefully that's not too confusing. And then, bam, what I should have, if I've done all this right, is it should move to the next space and then turn back into a block. Back into a push block. And so now I can push the block 1 space at a time. And the last thing that I need to do, which we're definitely way over time to do today, is see if I'm pushed into a trigger spot. And we'll do that tomorrow. Wow, this took way longer than I feared, and there was a lot more code than I thought, but hopefully that was fun for some of you who kind of know what's going on. This should be a fun one to go through. And we pretty much have a working grid-based movement push block. And if you want to see it even cooler, what I can do is if I look at my push block script here, I'm going to make it move at a speed of 1 instead of a speed of 2. So my push block, instead of moving a speed, I'm going to bump it by 1, and I'm going to move it FF, and I'm going to move FF, and I'm going to bump it by 1 and make it move at a speed of F and bump it by 1. Okay. So now it might look even more sort of like that Zelda style push block. And Zelda, by the way, used the same trick for push blocks, which is why I don't know why they only move one space. That was just a design decision, I guess. But like now, you can really sort of see. Oh, yes, it works. So push block. Awesome. Now I can kick the block around. And who knows what's going to happen when I hit the edges, because I never made any allocation for if it's in a solid position. So, all kinds of things might happen if I start to put it in a solid position. But we're off to a good start here. I know that was a super long one. Thanks for hanging with me. I have to go and take care of the rest of my day. Guys, I'll see you on day 18.